Hey guys, welcome back to physics here. The first video here on friction force on an inclined plane, there was no sound and I have no idea why. So I'm gonna sort of voice over this one, so it might be a little bit different than some of the other ones, but it'll work well. And one cool thing is I can make things go faster. Watch how fast I can write. Woo! So anyways, so this is friction on an inclined plane, and what we've been learning before would be the idea of just friction moving on a flat surface. And so friction force equals the coefficient times the force normal. But what if we have friction going on an incline like this, when you're going downhill? You're going to have the force of gravity pulling on it, but not completely, because it's on an incline, so gravity only pulls straight down. So let's say that we've got a box that's 10 kilograms and we're on a plane that's 30 degrees, right? So what do we know about this situation? Well, we know that the force of gravity pulls vertical. So gravity is going to pull straight down on that box. So let's see if I draw, I think I'm about to draw a vertical force vector from that box. Come on, you know you want to. And it's coming. Wait for it. Wait for it. Still coming. Looks like I'm going over the force friction equals the coefficient. Oh, also I told you that the coefficient in this, coefficient of kinetic friction equals 0.50 in this particular scenario. So I got a box going down an inclined plane. It's a 10 kilogram box and it's at a 30-degree slant. So what do we know? Well, we know that that box at 10 kilograms with the force of gravity is going to have a certain force. Now that force is going to pull straight down from that box, vertical. There, that's what I was waiting for. All right, so that's a vertical line. So notice how that vertical line is, of course, not pulling completely down the inclined plane, but just straight down. Okay, but because the plane is at a slant like that, it's going to pull somewhat down, right? But what we're going to have to do is we're going to have to take this force of gravity and figure out the component vectors to figure out what force it's actually going to pull down that plane, because not all of gravity is going to be going down that direction. So I can calculate the actual force of that vector, because that one straight down is the force of gravity. So it's going to be the 10 kilogram box times 9.8. So that's 98 newtons, right? So some of the other vectors that I want, well, I want to know the vector that is going to line up with the force of friction. And the force of friction is going to be a vector that is opposite to the force going down the hill. So in order to find force friction, remember, you got to have force normal. And so force normal is going to be a force parallel to the surface that the box is on. So that's the vector that I just drew right there. That's going to be the force normal force. So here we see we're starting to form a triangle right here. And now the last vector that I want in my triangle, I want to make parallel to the line of the incline. Now, what happens when I do that is I end up having a triangle, because that force normal line is exactly perpendicular to the inclined plane, right? And because that line is exactly perpendicular, if I draw a line parallel to the inclined plane, that forms a right angle, and that triangle right there then is going to be the same triangle as my inclined plane. And so that's going to make that angle right there also 30 degrees. So there it is. So that's a 30-degree angle right there. So now I know the angle of that, and I know that the hypotenuse of that particular triangle is 98 newtons. So let's see if I can erase that 98 newtons, because it's right in the middle of my attaboy. All right. Like I said, this is a voiceover dubs that for some reason the audio didn't work the first time. But so anyway, so there's my hypotenuse of my triangle is 98 degrees. Now remember, that is a congruent triangle because that one line, which is force normal, is perpendicular, and the other part of the triangle, the opposite, is parallel. And so because of that, it forms a triangle with the exact same angle as the inclined plane. So now I can use my SOHCAHTOA. So if I use the SOH, the sine of the angle theta equals the opposite over the hypotenuse, right? So what I've got is the sine of 30, because my angle right there is 30 degrees. So the sine of 30 equals the opposite, and let's call the opposite F sub D, so like the force downhill, so the downhill force, and it's going to be divided by 98 because that's the hypotenuse, because SOH, the sine of the angle theta, equals the opposite over the hypotenuse, and the opposite, that's going to be the same force. If you look at that force vector right there, opposite of the 30-degree angle is that force of that triangle that's going to come off, that's going to be pulling that box down the hill right there. So we figure that out to be 49 newtons. So now we know the actual force that is pulling it down the hill. So 98 newtons is the total force of gravity, but the actual bit of that force of gravity that's actually contributing to pulling it down the hill is only 49 newtons. Now we also need to find the force normal. Now because the force of gravity is straight down, the force normal isn't going to be all of that 98 because some of that 98 newtons is pulling it down. We figured out that that was 49. And so the other component of that triangle right there, the line perpendicular, is going to represent the force of the inclined plane that's holding the box up. So to figure that out, we just take the cosine of the angle theta, which is so the cosine of 30, which is going to be the adjacent, which is the force normal, divided by the hypotenuse, which is 98. So cosine 30 times 98 is going to give us 85 newtons. So the force normal is 85 newtons. So now I can figure out my friction force, right? Because friction force equals the coefficient of kinetic friction times my force normal, right? And so that's what my friction force is going to be. And my friction force, of course, is going to be a force opposite to my motion. So my kinetic coefficient is 0.5. So now all I have to do is plug that in. So let's see if I go ahead and do that. I'm probably just droning on and on. Oh, I already did it. So, so 42.5 newtons is what you're going to get if you multiply 85 times 0.5. And that's pretty easy to figure out because you got half of 85. So 42.5 newtons is my friction force, right? So my friction force is going opposite to my force downhill. Now you can see that there's a net force. And so because there's a net force, there's going to be an acceleration. So what is the net force? Well, we have 49 going down and 42.5 pulling away from it. So all we're going to have to do is subtract 42.5 from 49 to see what's left over. And sure enough, we're left over with an acceleration vector or a force vector down of 6.5 newtons, right? So that's our net force. And we know that net force equals mass times acceleration. And since we know the mass, which is 10, right, then all we're going to have to do is divide 6.5 by 10. So that's going to give us an acceleration of 0.65 meters per second squared. Now, what we can do with that is a whole lot. I mean, if I gave you a time, we can figure out, you know, the exact velocity at which it is, and if I told you, anyway, we can figure out tons of information about this, only knowing the original mass and the angle of the plane and the coefficient of kinetic friction right there. So in the next video, what we're going to do is look at some different sort of scenarios with time and how we could figure out velocities and a whole bunch of other stuff using the same model or example right here. All right.